Hello, in this video we are going to mention how to use Neo4j graph database for facial recognition tasks. But before that, please like the video and do not forget to subscribe to the channel. Thank you for your all support in advance. We are going to install Neo4j community server first. To install Neo4j server, please visit Get Started and Download Center in the neo4j.com. Currently, I'm using Java 1.8 version. You can confirm your Java version with java-version command in your command prompt, and my Java is 1.8 and 1.8 compatible Neo4j server is 3.5 and nowadays as the latest version is 3.5.27. I'm going to install the Linux and Mac version for Neo4j and it will download a zip file. You just need to unzip the downloaded file in your environment. We will also Neo4j graph data science library, and Neo4j 3.5 is compatible with graph data science library 1.16. That's why I'm going to install it. Here I downloaded the Neo4j in my downloads folder and let's visit it. We actually copied the graph data science libraries jar into the plugins folder. Let's visit this folder as well. As seen, Neo4j graph data science standalone jar is stored in this plugins folder. To start your Neo4j server, please visit bin directory and here we are going to call this Neo4j command. In your Windows platforms, this should be neo4j.bat. Here we are also going to pass console argument to the Neo4j. Neo4j server is running and we can access it with 7474 port in our browser. Let's visit this address first. We are going to log into the system with Neo4j user and Neo4j password. When you log into the system once, it will enforce you to the change the password. We are connected to the server. We will be able to create nodes and edges with this Neo4j console. I'm going to create nodes for the unit test items of the Deepface library. You can access those items with this URL. To access the items in the Deepface unit test folder, I'm going to need the OS module of Python programming language. This module offers a walk function and we're going to pass the path here, Deepface tests and dataset, and let's see what this function returns. It's going to return root directories and files. Let's print files here first. It returns a list. That's why I'm going to build a for loop here. For file in files and print each file here. It returns some JPEG files and some pickle files. That's why I'm going to check the extension of the file. If .jpeg in the file, let's print it. Those are the unit test items of the Deepface library. We can get the exact path of that file. Let's print root plus file. That's the exact path and that's the file name. I'm going to store root plus file, in other words the exact path and name of the file, in image paths list. It's going to be a Python list and here I'm going to append root plus file. Let's see image paths here. It stores the exact image of the unit test items. Now we are going to represent those facial images as vectors with Deepface library. That's why I'm going to import from Deepface, import Deepface. The first letters of the deep and face is uppercase. Here I'm going to build a model once. Model is going to be Deepface dot build model, and here I'm going to pass the model name, and it's going to be FaceNet. Now we are going to iterate over those items. That's why I'm going to build a for loop for image path in image paths, and here let's image path first. Now I'm going to read each item first and apply pre-processing stages, which are detection and alignment. That's why here I'm going to import from deepface.commons and import functions. Here functions module offers a pre-process phase function, and this function handles detection and alignment. Here we are going to pass the exact image path as input. Also we are going to pass the target size argument, and it's going to be 160 times 160. Actually this is the expected shape of the FaceNet model, and this is going to be my image. I will not print its name anymore. This pre-process phase function handles detection and alignment, and we then represent facial images as vectors. To represent images we are going to call model.predict function and pass image as input and get its 0 index value, and this is going to be my embedding. Let's see the first one. Let's see the embedding of the first one. It returns an array, and let's see its shape. Actually FaceNet model returns 128 dimensional vectors. That's the output. Also let's see the image path of the first item. We are going to store this item into the graph database, but I just want to store this image 36 part of the image path. That's why I'm going to call split function and split by slash and get the latest one. Now I would like to discard the .jpg part. That's why I'm going to split it with .character and get its first item. In this way I'm going to get the raw image name. This is going to be the label. Here before the for loop let's create a instances dictionary. Here I'm going to set the instances label is going to be embedding, but I'm going to store the embedding as Python list instead of numpy array. I'm going to remove the break line and run this for loop for all items. Let's print instances case values first. Those are the labels of the images, and for example let's see the content for image 36. This is going to return the embedding. As seen, it returns 128 dimensional vector. Let's build another for loop for label in instances dot case, and let's print label here first and get its embedding. Instances get label value. Let's print the embedding as well. and I'm going to do it for the first item again. This is the embedding of the image 36. Now I'm going to create insert statement for each item. Statement is going to be merge, and in the parentheses face, and here I'm going to put a curly bracket. Name is going to be, here we're going to pass the string argument and pass its value as label. Then set face dot embedding property is going to be string argument, and here it's going to be embedding. Actually there was a typo here. Let's print the statement for the first item, and here I'm going to write here break, and this is the first insert statement. Here I'm going to change, actually add string argument for the lower face and pass label content here as well. Image 36-face, here image 36-face dot embedding is equal to these values. This is the single insert statement, and let's store all statements here in a text. Here I'm going to append the content of statement to the statements plus equal statement, but here I forgot to add \n, and then I'm going to remove break and print lines. Let's see the content of statements. There are tons of items. Now I can copy those merge text statements to the Neo4j console here, but there's a better way exists. I'm going to import Neo4j client for Python from Neo4j import graph database and also basic authentication. Here driver is equal to graph database dot driver. Here this function expects URI. It's going to be, actually it was mentioned here, bold localhost, and its port as 7687, and this function also expects authentication. Here I'm going to pass the basic authentication and pass username and password. That was Neo4j and Neo4j. Then session is going to be driver.session. Here transaction is going to be session.begin transaction. Now transactions dot run, and here let's pass the tons of statements. Then committed transaction dot commit. These statements were run in the Neo4j server. We can check it here. Let's jump to the Neo4j console, and in the left please click database information, and let's see the content of face. As seen, our images were created as nodes in our graph database. We can change the view from graph to table to see the raw content of nodes. As seen here, the name and embedding properties were set in our graph database. Here we don't know anything about those nodes. Actually those are facial images of some people, but some nodes could be belong to same person. We need to find the relation between nodes of the same identities. Let's write a query to find the distances between nodes. Match person 1 in face nodes, then match person 2 in face nodes as well, where person 1 name and person 2 name should be different. Then return person 1's name as source, person 2 name as target, and then I'm going to call graph data science dot alpha dot similarity dot Euclidean distance, and here I'm going to pass person1 dot embedding and person2 dot embedding. Its alias is distance, and here I'm going to order by distance ascendingly, and that's limit to 10. This is my core query, and let's run it. As seen, it returns the image pairs and the distance between the pairs. We know that the threshold value for the FaceNet face recognition model and Euclidean distance is 10. In other words, if the image pair has a distance value is less than or equal to 10, then they are same person. Otherwise, they are different persons. Let's create edges between nodes if this condition is satisfied. Let's paste the raw query here. We are going to change this query a little bit. Here I'm not going to return anything, that's why I'm going to change this term to with and get person 1 and person 2 as is with person 1 and person 2, and also get the distance value between those nodes. Then here I'm going to add a where condition, and the distance value should be less than to the threshold value 10. If this condition is satisfied, then create an edge from person 1 to person 2, and here in the bracket e to distance, and here set e dot distance value to the distance value came from here. And this is the query I'm going to use to create edges between nodes. As seen, it creates 115 relationships or edges between nodes. Let's see our visual graph again. As seen, it actually has some edges between nodes, and actually there are obvious clusters, but notice that we limit 25 items here. Let's run it for all items. Interesting, there are obvious clusters in our dataset. Let's focus on, for example, this cluster. Here image 1 is Angelina Jolie, then it's connected to image 10 and image 11 as well. Those are Angelina Jolie. They are connected to image 6, image 7, image 2, and finally image 4. As seen, there are different identities in this folder, but this cluster represents the identity of Angelina Jolie. What's more, let's mention this cluster. It begins with image 27. It's Katy Perry is connected to 26, Katy Perry as well. 28 is Katy Perry as well. It jumps to 45. It's Katy Perry as well. 42 is Katy Perry. 46 is Katy Perry. 43 is Katy Perry, and finally 44 is Katy Perry. And this cluster represents the identity of Katy Perry, and it seems there are obvious clusters in our facial dataset, and we can actually do it with the power of graph database. We have mentioned how to use Neo4j graph database in facial recognition tasks. If you like this video, please like it, and do not forget to subscribe to the channel. Thank you for your all support in advance, and thank you all for watching, and see you next time.